Hello and welcome to week 2 in biopsychology, and we have 2 chapters that we're going to cover this week. First, chapter 1 on the structure and function of the nervous system, and then chapter 2, neurophysiology. Now in chapter 1 we're looking at gross anatomy, looking at the brain, the central nervous system, the peripheral nervous system. We're looking at the sympathetic, parasympathetic systems, all of these, kind of a general gross anatomy. And so the first discussion focuses itself on the sympathetic and parasympathetic systems, the systems that activate and then deactivate us in terms of, most commonly talked about, our fight or flight system, but it has everything it's also activated when we're waking up and when we're going to sleep. I mean, it's kind of how aroused are we, how awake are we, is going to be determined by that system. So you ask about how the parasympathetic system activates you when you are scared or surprised, and then what do you do or what are you aware of that you engage in order to have your sympathetic system calm you down again. So expressing some stories, sharing some ideas about how you do that. The first assignment is a slideshow. I want you to use PowerPoint or Keynote, and you are going to submit this file as an original Keynote or PowerPoint file. It's not a Word document or a PDF. I want you to submit these as files. And what you're going to do is you're going to explore 3 types of brain imaging. You're going to find an image from that type of brain imaging. You're going to describe that type of brain imaging. And you are going to look up a peer-reviewed article that uses that imaging. One for each one of the different kinds of imaging techniques. So if you're looking at an MRI, you want an MRI image, you want a description of what an MRI is, and you want to describe a research article that uses that particular technology and what did they find using that particular technology. Now, to do that research, you're going to have to access either Google Scholar or the EBSCO system here at the college. So make sure that your resource is peer-reviewed. You will do a citation within one of the slides for each one of the articles. I want to see those APA citations right in there so I know where these articles are and where they came from, and pretty much laying out an example, image, description, and research for each one of those brain imaging methodologies that are there. So that takes care of chapter 1. Chapter 2, we go into neurophysiology a little bit more in depth in terms of the structure of the nervous system, primarily the neuron and the synapse and one of those things. We'll be getting into the chemistry next, so there's even deeper there. One of the things that I introduced is the myelin, the development of myelin sheathing on the external surface of neurons that creates what we call white matter. White matter is in the peripheral nervous system, the spinal cord, and primarily within the brain, not a whole lot of white matter, but except for the corpus callosum, which is that mesh of fibers that connects the left and right hemisphere. And so, but it is a very, very critical because the myelin sheath increases the efficiency of neuron signal propagation across the nerve and increases the speed. So on the peripheral nervous system where you have to go really far, that nerve impulse has to travel much faster. So we've adapted our bodies to develop this myelin sheath to increase the speed of our nervous system. And individuals with multiple sclerosis, of which Maine is one of the highest incidents of MS in the U.S., is a deficiency in the myelin system. I'm having you explore that just simply for interest. This is affecting my life personally. My niece was very recently diagnosed with MS, a form of MS that is not progressive, but it'll come up. It flares up every once in a while, and she's been having struggles with this, not knowing what it was. She's both thankful that she now knows what it is, and very scared about what it means for the rest of her life. So it's a big deal going on in my family right now, and as she copes with that, she's a young person in her 20s, and this is quite a shock to the system here. So so doing some research on MS, if you know of people who have that disorder, sharing what you've learned and whatnot on this discussion. In terms of the quiz, a lot of this chapter has focused on the electrical, biological, chemical process that exists within a neuron. Now, a neuron that is not firing, is that what we would call, that neuron is currently in a resting potential. That means, potential means, like, just as if we use the word when we're talking about someone having potential, it means there's something there and it's ready to go. It just needs a trigger to go. There's an inequality. There's a slightly positive charge on the outside of the cell and a slightly negative charge on the inside of the cell. Now, in this quiz, I'm asking you to describe 3 different processes that are involved in the creation of that potential, meaning that inequality. Call it an inequality. It's more plus on the outside, more positively charged on the outside, more negatively charged on the inside. Diffusion and electrostatic pressure are 2 processes that exist in nature. These exist in plants, they exist within saline solutions, they exist within chemistry, within rocks, within inorganic chemistry. Diffusion and electrostatic pressure would normally equate the plus and minus, so they'd be the same on either side. If left to their own devices, this is very critical to know, left to their own devices, diffusion would negate that potential. Electrostatic pressure would negate that potential. You understand that from inorganic chemistry. The key here is the sodium-potassium pump. That differentiates non-life from life. The presence of life is what dictates the creation of that inequality across the membrane. So this is worthy of a whole video I'm planning on doing later this week. Again, given its own devices, diffusion, which you're going to describe, electrostatic pressure, which you're going to describe, the end product of those left to their own devices would negate the potential. There would be no potential. There would be no difference across the membrane. It's the sodium pump that creates that difference, and it gets the neuron ready to fire. So it's a very interesting and dynamic system of 2 inorganic processes being influenced by an organic, life-sustaining process, the sodium-potassium pump. So you're going to be defining each one, and within the set of those definitions, I should see that the idea that the first 2 would negate the potential, but the last one, the sodium-potassium pump, is what creates the difference between the inside of the cell and the outside of the cell. Make sure that you successfully define each one of those and understand their relationship in terms of ultimately producing the resting potential within our nervous system, keyed up, ready to go, ready to fire when called upon. So that is our chapter 1 and chapter 2. It's kind of a heavy content week, but stick to it, get right in there, do the discussions, read all the material, including the textbook as a reference manual. Make sure that you get into that to get all the deep stuff out of this. And but I think these areas here, the growth structure, and now this whole idea of the neuron, the impulse, and the myelin sheath, sort of the key domains within understanding everything that we do from this point on. So have a great week learning all of this material. Send me any questions that you might have, and I'll talk to you later.